Does this video make sense?
Captain, the ship is changing course, coming in on attack vector. I think it knows we're here.
Ask yourself, should it be an attack vector or an attack scalar? Welcome to Flip Physics. Today we're going to talk about vectors. At the start of this video I showed you a clip and asked you whether it should be an attack vector or an attack scalar. Now that was just a little test to see what you remember from the scalars and vectors video. A vector has a particular direction, so an attack vector would be something attacking in a particular direction. So that terminology makes sense. There's actually nothing wrong with it at all. We've also discussed one-dimensional motion, and we said that we'd fully discuss that before we move on to two-dimensional motion. Now is the time to do that properly, to give you the skills that you need to solve two-dimensional problems. How do we solve problems in two dimensions? The answer is found in vectors. Before vectors were understood, we thought objects flying through the air just kind of kept going for a while and then lost their impetus and fell straight down. It was kind of like Roadrunner physics. But thanks to vector mathematics, we can make much better sense of what's happening. In mathematics, we draw a vector as an arrow. We can add vectors by putting them tip to tail, like this. Or we can subtract vectors by placing them like this. But in physics, our biggest concern is how do we take things one dimension at a time? We don't want to deal with both at the same time, that makes it too complicated. All our equations so far only work in one dimension. So if we're going to use them, we're going to need to split a two-dimensional vector into an x dimension and a y dimension. So let's say a pirate ship is attacking a British fort, and terrible people as they are, the British want to fire a cannon at that pirate ship.
To your stations, we're under attack! Roll out the cannons! Return fire!
If they fire straight at the ship, what will happen? As soon as the cannonball leaves the cannon, it will start falling under gravity, and it will hit in front of the boat. It will land in the water. Instead, they need to fire up at a slight angle, and they need to figure out what angle they need to fire at in order to hit the ship. But how can they do that? What they need to do is analyze the motion of the cannonball in both the x dimension and the y dimension. Let's say that the cannon is fired at an angle of 30 degrees. And let's also say that the cannonball leaves the cannon with a muzzle velocity of, say, 90 meters per second. That's pretty realistic for a cannonball. By firing it at that angle, they're firing it both up and sideways. That means that the 90 meters per second can be broken down into an up velocity and a left velocity. An up part and a left part. We call these components, a vertical component and a horizontal component. The x component, left, and the y component, up. So you can calculate the size of these components by making what's called a vector triangle. Take this arrow and move it here to make a triangle. And then use SOHCAHTOA from your math classes to calculate these sides of the triangle, the x component and the y component. By doing that, you'll end up with these two equations. You'll use sine to figure out the vertical component, and you'll use cosine to figure out the horizontal component. Plug the numbers in that we already have, and solve. Do a little bit of mathematical rearrangement to solve this, to make the missing numbers the subject, and you'll find out that 90 meters per second is made up of these values. We get 45 meters per second up, and approximately 78 meters per second left. So when you shoot a cannonball at 30 degrees with a speed of 90 meters per second, that's equivalent to shooting it up at 45 meters per second, and shooting it sideways, left in this case, at 78 meters per second. It's a combination of those two things. You can make a vector triangle like this for any vector quantity in physics, from force to electric field to all kinds of other stuff that we're going to study over the course of this year. Any value that points diagonally at an angle, we can calculate the two components that make it up. So once you've broken the velocity into those two components, we can use those numbers in the equations that we've already seen. This x velocity becomes our value for the velocity in the x direction, vx. Since the x velocity doesn't change, this is a constant value. There's nothing in the x direction to speed up or slow down our cannonball. It would just keep going until something stops it. And this value for the y component becomes our vi, our initial velocity in the y direction. Because in the y direction we've got this acceleration due to gravity, we've got this constant acceleration. So that's our vi that goes into our constant acceleration equations. That velocity in the y direction will change as soon as it leaves the cannon. This is constantly changing because of gravity pulling it down, accelerating it down. So it's probably time to do some practice again, but once you get to grips with this, you'll know exactly where to point your cannon. I mean, if you wanted to sink pirate ships, which you wouldn't, because pirates are awesome.
Man those waiters!
Thanks for watching Flip Physics. Please comment below with your questions, thoughts and suggestions. You can also like, subscribe or go to our website flipphysics.net. Until next time.
Don't mess with me.